thank God. Learn a little about what's called HITL, HITL. That is human in the loop. That's the process by which engineers and scientists and physicists design systems so that somebody in a 500-pound spacesuit, albeit operating in low gravity, can interface with, on the real world, would be a golf cart. And the problems are immense. There are electrical charging problems, there are human ergonomics problems. It's also utterly fascinating. So now I'm going to shut up about my background, and I want to go on and talk a little bit about Virtus Solis. And I'm really pleased to see David Berger is here and Tom Jemison. Tom is on our board of directors, our industrial advisory board. You can look that up. And David Berger is one of the original members of the company. He's what you'd call in the executive team, the core team. He manages and handles government affairs, licensing issues, generally the entire political arenas that you have to travel into to work in space programs. He's also a very bright guy, 30-year mayor in Ohio, which in itself is an extraordinary accomplishment. And I'm delighted he's here. And maybe if there's time, he can say a couple of words. I was invited to join Virtus Solis in early 22. Came at a good time. The gentleman who introduced us was also one of Virtus Solis' original investors. In fact, he may have been the first one. And I'd like you to look him up, and if he'll accept you, hook up with him on LinkedIn. His name is Pablos Holman, Pablos, Pablo with an S, Holman. His title is Deep Futurist, and his little truck, as I'll have with people who call themselves futurists, because I think it's pompous, Pablos really does own claim to it. He's a brilliant engineer, but that's the 10th part of he's a true visionary. And he's brought up some very important technologies. And so he's someone that if you follow him, I think it'll be a great help in anything that you're planning to do. Virtus' core technology and core purpose is to build a type of satellite which will be organized into vast arrays. Some people call them constellations, but in fact, the Virtus satellites are connected to each other. There's some technological aspects of it, and I'll direct you to the website as well. The purpose of these satellites, which are about 1 meter square, is to convert photovoltaic power photons from the sun into microwave energy. Now, again, we're not going to go into a lecture about how photovoltaics actually work, but you take energy from the sun, you send it down to the ground on solar arrays, the same kind of little systems that run the light meter in your old camera, or the systems on people's roofs. And that produces, on a really good day, at the maximum efficiency, about 30% translated power. You can easily, with the arrays on a roof, you can easily power a house, easily, and sell energy back. We've taken another turn on it. And the two founders of our company, John Bucknell and Ed Tate, and I'm saying this with 40 years working around geniuses, men and women who are far better educated than I ever will be, and far better at their jobs, but I've had the privilege of working with them. These two guys, Ed and John, are among the brightest engineers I've ever met. And they're polymaths as well. They've got several different degrees. And between them, they've come up with the antenna technology, the conversion technology to produce energy that competes favorably with nuclear in terms of cost and with photovoltaic in terms of simplicity of operations. It surpasses them in several critical ways. Although its infrastructure is expensive, like a nuclear plant, it's also safely off the planet. So the typical vulnerability points for any type of ground-based nuclear power have to do with cooling or releases of toxics or radioactives. None of those are possibilities. Terrorist attacks are still a possibility all over the planet. It'd be very difficult for anyone to bring these things down. It also operates, unlike standard photovoltaic or wind, 24/7. So again, I'll send you to the site, but without going on about it, we have chosen a type of orbit that allows 3 of our floating orbiting arrays to cover the planet 24/7 with energy. The potential, and we do these calculations based on a formula, which I'll also put up for you. is for this system to provide enough electrical power to solve the planet's needs. And all of the planet's electrical needs. There'll always be a place for solar and on a small scale basis, but this is energy that will be distributed through existing utility systems and or standalone ground stations. I am deeply proud to have been asked to join this group. And I ask you all to take a look at this, if only to see whether or not it suits your interests. So I'm shutting up again.
What are some of the trends that are happening with our energy needs that Virtus Solis is going to help really solve?
I'm going to put up something here before I put up the Virtus Solis site.
Everybody has access through the newsletter, but it's also in the LinkedIn post. So you'll be able to see their LinkedIn and to get the website there. Yeah.
All right. You'll be able to see, I think, LCOE.
Yeah. Okay.
That acronym stands for Levelized Cost of Energy. It's an extraordinarily complex, basically it's an equation. It combines algorithms, and what it provides at the end result is an answer for, under XYZ conditions, what is the levelized cost of producing energy? And let's say the nuclear plant is producing energy at net 4 cents a kilowatt hour, which is very low. Or photovoltaic is producing energy at 45 cents or 50 cents, and those numbers can climb. We use those calculations, principally Ed, Mitchell, John, and a few of our other highly technical people use those to do the comparisons that allow us to actually understand the entire cost of producing 1 unit of energy. And some people use the term externalities. It's used in the financial market. For instance, how much does it cost to produce an ounce of gold or platinum? It costs XYZ. What about the environmental cleanup costs? What about the costs of rising labor costs? What about liability costs? What about damages or other exigencies that occur around the process? And LCOE was built by probably the largest utility organizations in the world and academia. Based on that, our designs stand up favorably to everything, including nuclear, which is generally much lower than fossil. But again, without the costs of decommissioning a nuclear plant. Let's talk about the evolution of aerospace and energy technology.
Before we get, and I think a good segue to get there is, what are the current challenges to be able to get these solar arrays in space with respect to the economic challenges, the tonnage requirements, things like that?
Good question. In the late 19th century, if a farmer wanted to get his product to market in central Canada, he had to have a wagon. And if he was lucky, there'd be a railhead somewhere in the vicinity. By the time you're done, the only real reason to have small farms was to feed your family. And industrialization and transportation changed all that. As a dear friend of mine says, who is one of the engineers who worked on Ariane, the space isn't going anywhere. We were. And the only way we could first explore and then exploit was to have transportation systems that made economic sense. In space, the number one issue, quite apart from safety and technology and what have you, is the cost for moving mass from the Earth's surface out. And there are a lot of ways to calculate this, but the most realistic numbers come from the Saturn era, the Apollo era, when we first Gemini and Mercury, but when we first started launching capable ships. In those days, it was around $600,000 a pound. It quickly dropped after the Saturns were no longer used, down into the tens of thousands, hovering around 80, 90,000. Sometimes they used kilos. And then in the later stages of early space, it got down around on the shuttle and so forth. At space station, it was about 20 down to 5,000 using very large rockets. This is no kind of economical avenue to prosperity if you're just looking to open up Joe's hamburger stand in orbit. It doesn't work that way. And there's also a means of calculating all of the costs of putting something into orbit. So what we have now, skipping over 20 years, is with SpaceX, and probably in another 10 years or so with Blue Origin, and with Electron, the Rocket Lab people, Spoke, Firefly, we have the ability now to put stuff into orbit at far lower costs. And Musk is now talking about $500 a pound. And again, this is all dependent on something that never existed in space before, which was mass manufacturing. And whatever else may be said about Elon and the folks at Tesla or anyone else, Musk made one critical decision that Blue Origin failed to make, and that was to find the best people in the world and leave them alone. Not put in micromanagers, he's one, but not put in micromanagers who are managing to time and budgets. That's the death of any space program. That's not how we build stuff, and it's not how we can build it. The cost of getting to orbit is dropping. And our principal challenge at Virtus Solis, our principal challenge is working the economics of getting those thousands and thousands of monocoque satellites into orbit. We are our vendor of choice, of course, will be SpaceX, but again, with the build out of other companies, I think there'll be more and more competition. And I believe our models will probably always use the Falcon series or something like them, but who knows in the future. So that's the number one factor. Number two factor is the technology. And it's interesting. Anytime you look at what's called first adopters, you'll see that they're typically people who don't really know anything about something, but they'll bet on it. Famously, Steve Jobs invented something, and he did invent the iPhone. Whatever anybody may say, he invented it, the core. He literally called it a solution to a problem that doesn't yet exist. And much of Apple's marketing effort was focused on the capabilities, not the technology. And that's what got them where they are. Are we building a solution for a problem that doesn't exist? Absolutely the reverse. One of the biggest problems, if not the biggest problem facing humanity, is energy. Now, anybody who goes into a science class in third grade learns that the sun produces enough energy on an area the size of New Zealand to power the entire planet. There are two issues with that. Who wants to give up an area the size of New Zealand and build a transmission system all over the world? So do you do distributed? One way or another, that cat needs to be skinned. And our system, as I said, provides worldwide power beam coverage 24/7. That is dependent, in turn, on the area that David, in particular, is specialized on. How do we manage jurisdictions? How do we build customers? How do countries, which have differential needs and differential resources, buy that power? How will, for instance, Central Congo be able to avoid power when South Africa is paying 10 times as much per unit? That's the reason that Virtus Solis, as small and as we are and growing, is relying on the vertical model. This is the vertical monopoly model, basically. It's very similar to how SpaceX was built. The difference being was SpaceX had all the technology. What they had to do was figure out production costs. For us, our modeling and simulation is first rate. It's as good as anything I've ever seen at IBM or RAND or NASA for that matter. And we're very fortunate in having that, our core technical team. But the business of supplying power also means getting it from place to place. Yeah. Virtus's ground stations will be on average about a square kilometer, probably 3 or 4 times less surface area than is required for standard photovoltaic.